Am I audible to both of you?
Yes, ma'am.
All right. So, see, in the last class, we were discussing resistance and resistivity and basic formula of resistance and resistivity we have discussed. And these three figures, I told you to remember their values as it is for the resistance. Now, we have done a question, not a question, a case we did in the class, variation of resistance with temperature. Variation of resistance with temperature. So the formula was quite simple. We have discussed one of the formula was, yes, anybody who remembers? In current electricity we did variation of resistance with temperature. Resistance at any room temperature at any temperature is equal to resistance at the room temperature 1 plus alpha delta T. This is what we discussed. Now, this is what is limited to your syllabus. Here, this is the resistance at the temperature. This is basically the room temperature. Okay, this is the room temperature. Now, we have one more formula for resistivity. This was the formula for resistance. Similar formula for resistivity. See, R, you know already, R is equal to rho L by A. Yes, class? So if you know R is equal to rho L by A, the only variation is regarding the length and the area. Now, if a wire is there, for the same wire, the length and the area will not change. Length will remain this, area of the cross section will be this. So here we can write the resistivity or at any temperature is equal to resistance at the room temperature 1 plus alpha delta T. This is the formula, very much similar to what you've studied in the resistance formula. Okay, resistance was RT is equal to R naught 1 plus alpha delta T that we have studied. Rho T, this is the resistance at the resistivity at any temperature T. Rest of the things will remain the same. But alpha has a little different meaning here. It is instead of thermal coefficient of resistance, it is the thermal coefficient of resistivity. So same units and everything. This is the thermal coefficient of resistivity. Okay, thermal coefficient of resistivity. R naught is the resistivity at a temperature R naught, at a temperature T naught. T naught is again the room temperature, and RT is the any value of any resistance that is present. Okay, this is your resistivity. This is your resistance. So very similar. You don't have to remember anything else here. Now, similarly, here also the alpha's value, two things you need to remember. For the conductors, it has to be positive. Conductors or alloys, the value of alpha will be positive. And for semiconductors or insulators, it will be negative. Okay, that's what you need to remember here. And yes, sometimes equivalent alpha is also asked to you in the NEET paper. This won't come in your regular CBSE exam. Equivalent alpha. Like you have equivalent resistance, net resistance are effective that we write. So similarly, like the equivalent resistance, equivalent capacitance, you will have the equivalent alpha. So what is equivalent alpha? It's like, let's say this is one wire. See, let's say this is one wire. And here we have one more thick wire which is attached to it. Let's say here the resistance is some R2, the coefficient of the thermal resistivity is alpha 2. And here this is some R1 with a value alpha 1 like this. So two different Phis are now connected. Now we know this is all material dependent property. Depending upon the materials, the values of resistance, resistivity, these are different. So alpha equivalent alpha, when you are calculating in series, directly remember the formula for it. For series and parallel connection, if the wires are connected in series and if the wires are connected in parallel. So this is something that we have never discussed because this doesn't come in your regular exams. This can come in the NEET. Once a question came from the series, in fact, in the Ames paper, this series question was asked often, and it was modified using the conductivity. So you had to replace conductivity and all. So we'll see the question. So here alpha equivalent will be C. Like terms in series will come together. How? R1. So it will have alpha 1. Okay. So alpha 1 R1 plus alpha 2 R2. Okay. Then the sum of the resistance R1 plus R2. Like together, alpha 1 R1, alpha 2 R2. They'll be together. When you have parallel connection, then it will be R2 with the alpha 1. So you're in the equivalent, your alpha 1 will be there, but R2 will come. Plus, then you will have alpha 2 R1 divided by again the sum of R1 and R2. So this is very important, especially the series and in fact the parallel also. Both of these are important. And they can be replaced with conductivity. Remember, there was a question once asked and that was repeated even in the school exams of students. So alpha 1 R1 plus alpha 2 R2 by R1 plus R2 for the series. And for parallel, alpha 1 then R2. Alpha 2, so R1 divided by R1 plus R2. All right, class, do one thing, write it till here. Then we'll discuss some things about Ohm's law. Please write this. Is it clear till here to all?
Yes, ma'am.
All right, Zobita, what about you?
Yes, ma'am.
Oh, please write it. Done?
Yes, ma'am.
All right. Let's come to the Ohm's law then. Okay. The Ohm's law you already know, all of you. Just a little recap of it. Now, what all things we have not done in our regular classes, that those portions we'll be discussing here more. Okay. So regular Ohm's law, you already know V is equal to IR. Okay. When is this possible? When the temperature, pressure, these things are not varying, then we use the law V is equal to IR. Okay. One more thing we already know, potential is equal to electric field into distance. This is from our second chapter. Remember, E is equal to minus dV over dr. We had this formula. So based on this, V is equal to ED. Many times you have to equate both of these. Okay. When we are talking about the electric field, when we're talking about the distance, both of them can be used. So sometimes this is often used in the exam. Otherwise, see, when you have the formula V is equal to IR, let's put in the values. Now, current is equal to two values, I'll tell you, for current. One value for current, one for resistance. Current is equal to the current density multiplied to the area. This is one formula that we know for the for the current. What is this? This is basically the current density. Yes, class, I is equal to J into A. What is current density? Current per unit area. So what will be current? Current per unit area into area will give you current back, right? So current density into area will give you the current back. So this is one formula. And one formula of resistance we have already studied, R is equal to rho L by A. This is the second formula. So these two formula we know. Now let's put it in the Ohm's law. So what will we get? V is equal to J into A into rho into L by A. Area will be cancelled. J rho L. What will we get here? J into rho into L. So this is one formula for potential. Now see, if I bring potential here and length here, what will I be left with? J into rho. And what did we study? What is V by L, class? We've just studied this. What is this V by L?
Ma'am, R resistance. No.
No, not resistance. I discussed, recall all of you. What is it? Potential by length will be
Electric field.
electric field. Okay, V is equal to ED. That's what I have written here. I have written D here. Here I have taken it as L. So this is electric field. So this is one very important relationship we have. Apart from E is equal to sigma E. One is this is the vector form. Okay, this is Ohm's law in vector form. So electric field will be density by a density multiplied to the current density. Resistivity multiplied to the current density. Also, you can write this. See, what is this? Rho is equal to 1 by sigma. Sigma is equal to 1 by rho. So from here you can say J by sigma will be like equal to electric field. So if you have to write J is equal to sigma. So these are various formula you can use. This is basically known as the Ohm's law in vector form. This is known as Ohm's law in vector form. Okay, this formula is more important from the competition's perspective, class. Okay, and few formula you need to remember them as it is. The way I told you, remember the formula for resistances, few devices like this, the spheres, the concentric cylinders, the unequal pipe like this. Remember it for this part also. That I'll tell you. For cuboid, I'll tell you. For similarly concentric spheres and all, I'll tell you. Because if you remember them, it will be very easy to do when you appear for the mock tests and all. And for the actual paper, you will not need to uh, just solve everything in detail. You'll have the few formula you should remember, rest of the things you have to solve. Okay. So do one thing, write this part, till here, Ohm's law and Ohm's law in vector form. Then I'll tell you the various objects whose formula you should remember at one glance. Okay, please write it. Okay, look, for this figure, when you have a cuboid, when current is flowing through it, let's say I amount of current is flowing through it, okay? And here you are taking a segment in between, like this. You've just taken a sheet in between and you are calculating the electric field through it. Electric field, directly remember it is rho into J. Now J is current per unit area. So see, for the area, don't take the entire area of the cuboid. This will be equal to rho into I by AB. All right, AB will be the area. Okay, A is the area, B is the, A is one side, B is another side. It's like this. This is one side A, this is the second length B, like this. Whatever will be this length, AB, anyway, here also, anywhere, okay, A, B, like this. This will be the electric field. So directly remember that. And what else did we do? We did for unequal pipes as well, right? Second is if when we did it for unequal pipe. Let's say some I amount of current is flowing, and here the radius is, let's say, A, and here the bigger one has the radius B, the same thing which we took earlier as well. And resistivity is rho. So the current density, see, current density for the first area, this area will be current divided by pi A square, and current density for the second area, it will be I by pi B square. Look, I by pi A square for this, as if this is a circle here. And pi B square for this figure. Okay. So electric field also you will calculate individually. You will not get one combined electric field. When you will calculate E1, it will be rho into I by pi A square. Similarly, when you will calculate electric field for this region, it will be rho I by pi B square. That's okay. Individual points. Here you will calculate. Here you will calculate like. Then comes the concentric sphere, the third one which we discussed. So this will be like this. Here again, two radii you are going to take. One will be the inner one. Let's say from the center, the separation is some A. And till here it will be, let's say this is some point R. Okay, this is some point R that we are taking in between. Like in the toroid we have taken, let's say this is for generalizing, so that whenever you have any length, let's say you have this whole big radius as B, so you can generalize and put it for separate radii. You have the electric field is equal to rho into J. So electric field will be rho I by 4 pi small r square. Now you put the value of r separately, like if I want to calculate E1, it will be rho I by 4 pi small a square. And if I want to calculate E2, it will be rho I by 4 pi b square, like this. So here you will not have one single formula. You will have to calculate it separately for all the various formula. Is it clear till here? This is easy. I think easier than the resistance one. Here you have to remember less. The resistance one was more. Is this clear? Ibrahim, Jasleen, Jobita?
Ma'am. Yes, ma'am.
Yes.
Okay. Please make these figures, then we'll see mobility. Mobility also has one or two different questions. Please write it.
Ma'am, can you scroll up?
Done class? Till here? Okay. Coming to mobility. So basic formula of mobility we have studied. Anybody who remembers the formula of mobility? Mu was the symbol. Can anyone answer? Mobility formula. It was the ratio of two things. Yes, class, quickly tell. Current electricity, you've already studied. You've given the test as well. Mobility. It was drift velocity divided by electric field. Jesslyn is VD by, yes, very good, Jesslyn. Drift velocity by the electric field. So this is the formula for mobility. Now see, current, you know, NEAVD. This formula is also there. Electric field is rho into J. And J can be written as current per unit area. So rho into I, rho into J is current per unit area. This is the formula for electric field. Right, so if I put the value of Vd, see what will be the drift velocity from here? Drift velocity will be I by NEA. This is one formula. And electric field will be rho I by A. So mu will be, see, this is I by NEA. And we have the value of electric field equal to rho I by A. A will be cancelled, current will be cancelled. Formula of drift velocity is 1 by NE rho. This is the formula for the drift velocity. What are all the terms? I hope you know. Mu is the mobility. N is the number density, number of electrons that we take. E is the electronic charge. And rho is the resistivity. Okay. Now lots of theory portion we have seen. Based on these things, we will see the numericals, especially current and the current density one. Please quickly write this. Let's at least see one or two numericals. Please write this. See, class, this question says the current density in a cylindrical wire of radius 4 millimeter is 4 into 10 to the power 6. The current through the outer portion of the wire between the radial distance r by 2 and r is. So can any one of you tell me, out of the three cases that we did, is it matching with anyone? Or this is some independent case? Is it matching with any of it? See, class, the second one, if I make it uniform, this is a non-uniform because I was taking the extreme case. If I make it a uniform, it is basically saying that it's a concentric cylinder. Outer portion is there. See, understand what the question says. Current density of a cylindrical wire is given. Radius of the inner portion is given to you, and radius of the outer portion is given to you. Total current density is given, and it says between this half inner part, R to R by 2, this separation, what is the value of the current that we have to calculate, right? Dash pi ampere will be the answer. So pi is already given, the value we have to calculate. So it is actually like this. This is one cylinder. And the inner radius of this cylinder is also given, which is exactly half of the radius of the outer one. Okay, so here we have this inner radius. This is R by 2, and the outer one is of the radius pi. Now, this is what the question is saying. The current density of the radius 4 millimeter is given to us, 4 into 10 to the power 6. We have to get it, we have to get the current. So we know current density is what? Current is equal to current density multiplied to the area. This is given to us. This we have to find out. Do we know the area? Yes, we have the information about the radius. So why will not be able to calculate it? Got it? What is the area of this portion, class? If I ask you this portion, these kinds of figures often come concentric circles, concentric spheres, concentric cylinders in your NEET exam. NEET, JEE, both the papers. Yes, can anyone tell me how to calculate the area? Remember, you just have to consider the area of the cross section. Whatever I mark, that doesn't make an impact. You just have to consider the area of the cross section. That's it. That's what we study in current, right? When I was marking, I told you also is the area of the cross section. So here you just have to take I is equal to J pi r square. Now it will be bigger square minus the smaller square. If I write it in two steps, it will be like this. See. This will be current density into what is the area? Pi r square minus pi r square by 4. So from here, if I take j pi common, I'll be left with r square minus r square by 4. You take this LCM, you will be left with 4r square minus r square by 4. What is r 4r square minus r square? 3r square. Current is equal to J into pi into 3r square by 4. So a little limited value. Now you just have to put in the values here. What is current given? Current density 4 into 10 to the power 6. 4 into 10 to the power 6. Pi you never have to solve here in this case, right? You never had to. From the starting we were saving our pi because the question had dash pi. 3 into r square. Radius was given as 4. 4 into 10 to the power minus 3. 4 millimeter. 4 into 10 to the power minus 3 divided by 4. So this 4 will be cancelled. How much it will be? Okay, this is our square. So we have to square this. So 16, 3, 48. Yes. Look class, this will be 48 into 10 to the power 6 into pi into 10 to the power minus 6. This gets cancelled. This is 48 pi ampere. So answer here will be 48. Is this question clear? Any part you want me to repeat? Is it clear? Jobita Ibrahim, Jasleen.
Yes, ma'am.
Okay. Please write it. It's a very important question. Done.